So, what if you could predict the future? Okay, maybe not the whole future, but what if you could predict the price of a house just by knowing its size? Or guess a student's exam score based on how many hours they hit the books? Well, it's not magic. It's actually a really powerful and, believe it or not, super simple tool called linear regression. And today, we're going to pull back the curtain and see exactly how it works.
It all really boils down to one simple, fundamental question. If you know one thing, X, can you make a really good guess about another thing, Y? Right? Like, if you know how many miles a car has, can you estimate its price? Or if you know how much a company spends on ads, can you predict its sales? That's the puzzle we're here to solve.
And the answer, the solution to this big question is, well, it's surprisingly simple. We're going to use a line, a straight line. That's it. That's the secret weapon we're going to use to start making some seriously smart predictions. Okay, let's make this real with a classic example. Check out this table. On one side, we've got the number of hours a student studies, and on the other, the grade they got on a test. So 1 hour gets you a 40, 2 hours a 50, 3 hours a 60. You can already see it, can't you? There's definitely a pattern here. The more you study, the better your grade seems to be. Now, tables are fine, but a picture is worth 1,000 words, right? So what happens when we take that data and plot it on a graph? Each one of these dots represents one student. And boom, this is where it gets cool. You can literally see the relationship. The pattern just jumps right out at you. See how the dots are kind of forming a line moving up and to the right?
So what we can do now is take that general pattern and boil it down to one single straight line. Now, this isn't just some random line we're drawing. Oh no. This is what we call the line of best fit. It's the one line that does the best possible job of summarizing the trend in our data. You can think of it as our own personal prediction machine.
And now that we have this prediction machine, we can finally answer our question. Let's say a new student comes along and they study for 5 hours. What grade can they expect? Well, it's easy. We just find 5 hours on the bottom, go straight up until we hit our line, and then look across to see the grade. And just like that, our line predicts they'll get about an 80. See, we just made a prediction based on data.
Okay, so this line seems pretty magical, but how does it actually work? What's the engine running under the hood? Well, it all comes down to a super simple formula that I'm willing to bet you've seen before, probably back in math class.
Yep, it's the old classic, y equals mx plus b. Now, don't tune out, it's way simpler than it looks, I promise. In our example, y is just the grade we're trying to predict. X is the number of study hours, the thing we already know. M is the slope. Think of it as the power of each study hour. It tells you how many extra points you get for each hour you study. And B, that's just the starting point, like what grade you'd get if you didn't study at all.
So for our line, let's say the formula is marks equals 10 times the hours you study plus a starting score of 30. So what about that student who studied for 5 hours? Let's do the math. We just plug in the 5. 10 times 5 is 50, plus our starting 30 gives us 80. Exactly what the line on the graph told us. It's really just a simple recipe.
Okay, but hold on a second. I mean, you could draw a ton of different lines through those dots, right? So how does the computer figure out which one is the absolute, hands-down, best possible line? This is the million-dollar question.
Well, to answer that, we have to face a simple truth. Our model isn't a psychic. It's not looking into a crystal ball. It's just making really, really educated guesses. And because they're guesses, they're not always going to be 100% perfect. There's almost always going to be a little bit of a gap between what we predict and what actually happens.
Let's say our line predicted a student would get an 80, but when they took the test, their actual score was a 75. That little 5-point difference, that gap between the prediction and reality, that's what we call error.
And that right there is the key. The best line is simply the one that makes the smallest mistakes overall. It's the line where if you add up all those little gaps, all those errors for every single one of our data points, that total amount of error is as tiny as it can possibly get.
And there's a cool mathematical method for finding this perfect line. It's called least squares. And really, the name says it all. Its whole goal is to find the one line where the total error is the least it can possibly be. Simple as that. All right, so we get the basic idea, right? Find the line with the least error. But how does this play out in the real world with much more complicated problems? Let's take a look.
I mean, think about it. In the real world, things are rarely that simple. A student's grade probably depends on more than just study time, right? And that's where things get even more powerful. This is called multiple linear regression. It's the exact same idea, but now we can feed our model more than just one thing.
Exactly. To get a better prediction for a student's grade, we could look at not just their study hours, but also how many hours of sleep they got, or what their previous grades were like. The model is smart enough to figure out how important each of these things is, kind of giving each one its own M value, its own slope, to make the final prediction even sharper.
And this is literally how those real estate websites work. When they give you a price estimate for a house, they're not just looking at its square footage. No way! They're feeding a multiple linear regression model things like the size, the zip code, the number of bedrooms. All of it gets crunched together to spit out that price you see online.
Okay, so now you basically have a predictive superpower. But you know what they say, with great power comes great responsibility. It's really important to know this tool's limits, to know when not to use it.
See, there's a reason it's called linear regression. It's all based on one big assumption, that the relationship you're looking at is a straight line. If the real pattern in your data is actually a curve, or if you have a few really wild outlier data points, then trying to force a straight line onto it, well, it's just not going to work. You're going to get some pretty bad predictions.
Here's a perfect example. Think about the connection between age and happiness. A lot of research shows it's not a straight line at all. It's more like a U-shape, where people are happier when they're young and old, but it dips a bit in the middle. If you tried to draw a straight line through that U-shape, it would be totally meaningless, right? It's all about using the right tool for the job.
So if you take away just one single thing from all of this, let it be this sentence right here. Linear regression predicts values by finding the absolute best straight line that fits your past data. That's it. It finds the historical pattern and just extends it forward.
It's such a simple concept, but it's incredibly powerful, and it's used everywhere, from predicting the stock market to medical research. The world is just full of these hidden patterns, these relationships between things, all just waiting to be found. And now you know the secret to finding them. So the only question left is, what will you predict next?